To provide Pakistani enterprises with cost-effective giant flywheels, their workshops turn to traditional sand casting for production. Though this method is slow, simple mechanical equipment can still produce structurally precise giant flywheels. Due to the flywheel's immense size, exceeding the capacity of traditional sandboxes, the craftsmen must dig a large pit in the ground to serve as a makeshift sandbox. They lay a layer of molding sand at the bottom of the pit, and experienced craftsmen can create a level base using a square tube and a level. They then poke small holes in the bottom with a stick and inject carbon dioxide, which hardens the sand. Once the base is solidified, they draw a 2.2-meter diameter circle to determine the main size of the flywheel mold and place a leveling device in the center to ensure the mold's flatness. Despite their outdated equipment, Pakistani craftsmen easily solve problems with simple tools. They build the mold's outer frame with bricks, fill it with molding sand, and compact it. If any uneven areas are found, they use the leveling device to smooth them out. Next, they start making the fan-shaped mold for the flywheel, which has a concave cross-section. To facilitate this shape, the craftsmen first create the flywheel circle separately. This process is relatively simple. Just fill with molding sand, compact it, and finally, solidify the sand with carbon dioxide to quickly obtain a fan-shaped mold. After demolding, they assemble it onto the casting base. Once the base's fan-shaped molds are in place, the craftsmen measure carefully to ensure each part is positioned correctly. Then they place 6 circular molds on the base, stacking fan-shaped molds on top, quickly completing the assembly like building blocks. Next, the craftsmen fill the gaps in the fan-shaped molds with molding sand, then use a high-power blower to clean up scattered sand. After cleaning, they place the central shaft hole mold in the exact center, constantly measuring and adjusting with a ruler to ensure precision. Then they begin to close the mold, surrounding it with molding sand to prevent iron leakage during casting. The pre-made molds are arranged in a circle. The mold covers are not completely sealed. They leave some holes for gases generated during casting. These are the exhaust holes and pouring spouts. To prevent the molds from shifting, they press several tons of weight on top of the molds. Once everything is in place, the flywheel sand mold is ready for casting. On the other side, the craftsmen select suitable metal materials for smelting, sourced from old machinery or other discarded metal products. They push the scrap into a large electric furnace, heat, and melt it. Under advanced equipment, scrap iron takes only 2 hours to melt completely into liquid iron. Then, using a hydraulic system, they open the furnace, pour out the impure iron, remove the impurities, and transfer the iron. The cast flywheel is enormous, transporting the iron to the flywheel casting model's location. The iron flows slowly through the channel. The craftsmen carefully observe the flow of iron in the sandbox, ensuring it fills the entire sandbox evenly. After casting, the iron needs to cool for 48 hours. Once cooled, they use a crane to extract the flywheel. Since the flywheel surface is covered with a large amount of molding sand, it must be cleaned thoroughly, especially the grooves in the flywheel, which require a high-power electric pick to break apart. Under the